All right, guys, I'm back for the last part of this. Excuse me. So if you realize that 2 goes into all these, you can reduce this and make it a little easier problem to solve. This becomes x squared, this becomes negative 5, and this becomes negative 24. Makes it much simpler to factor. We're trying to find factors of 24 that add up to 5, or factors of negative 24 that add up to negative 5. So you could think maybe 12 and 2, 24 and 1, 6 and 4, and hopefully you stumble upon 8 and 3. And then you got to think about the signs. Is it positive 8 or negative 8? Is it positive 3 or negative 3? This is telling you that one of them is negative, and this is telling you that the bigger one's negative. So hopefully you realize it's x minus 8 and x plus 3. And we've set this whole thing equal to 0. What value would you plug in there to make this equal 0? Positive 8. What value would plug in there to make this equal 0, this factor equal to 0, negative 3? So there's your two solutions. Now, if you plug them in, they both work. Like mathematically they work. Visually they don't work. This is an obtuse angle. Only one of these creates an obtuse angle. So like, this is the type of thing, if I put it on a test and asked you to interpret, I did this a while ago in chapter 1, had you interpret an answer and one of them gave you an acute and one of you gave an obtuse angle. If you plug the 8 in, 8 times 8 is 64. 64 times 2 is 128. That would work. If you plug the negative 3 in, negative 3 squared is 9. 9 times 2 is 18. That certainly doesn't look like 18 degrees. So definitely not drawn to scale. So if I had to choose, if I gave you in a direction like this, I would say get rid of the negative 3, and the 8's the only one that makes sense, and you proceed forward with that. If I don't put that on here, which I didn't on your paper, then either answer makes sense mathematically, and you accept both of them, because neither one gives you a negative angle if you plug them back in. Like I said, if you plug the 8 in, you get 128 here. Subtract from 180 to get this one, and you get 52, I think. Plug the 8 in over here. 8 times 5 is 40. 40 plus 24. You get 64. And of course these are congruent, so they're both 64. Done. Alright, you got 2 left on your paper. Again, this one, you can label these 3 angles, but I need you to extend a side, which again creates an exterior angle. Another opportunity to use the exterior angle theorem. Good time to pause, try it on your own. I'm going to just keep talking right through it. But I would suggest you label this thing and you go after it, see if you can set up an equation. Hopefully by this point in the notes, you've done 3 or 4 of these, you did a few for homework. You can set this up on your own. So hopefully you realize an exterior angle, this angle has got to be equal to the sum of these two. If you try to do something with y in the beginning, you get stuck. I had somebody in the other class say, these add up to 180. True. But if you add these 3 up, you end up with 2 variables in the same equation, which is a system. And we don't want to do a system if we don't have to. So 5x squared is equal to the sum of these two, the x squared plus 15 and the 85. These combine rather nicely. And you can subtract this to the other side. So now you've got 4x squared on the other side. These combine to give you 100. You could do this by factoring. I would just suggest you divide both sides by 4. X squared equals 25. And there are 2 valid answers here for x. X could be 5. Negative 5 is also possible. Even when you plug it in here, both of these locations, if you plug it in, it turns positive. So you plug the 5 in. 5 times 5 times 5. It's 125 for that angle. And of course, if this is 125, you can subtract to get that one. You could plug the 5 in over here. 5 squared is 25. 25 plus 15 gives you that angle. And you should get 40, and I think this ends up being 55. Alright, the last one on your paper. You got to draw it. If you don't draw it, you're probably not going to be able to do it. So sketch it. Label all the angles that were given. There were 2 angles given in this problem. This is probably a good time to pause, try to set it up on your own, stumble with it for a minute, and then at some point you'll break away and you'll find it's pretty easy. The stumbling point that most people have in the other classes, they didn't know where to put this 120. They wanted to have a set location for it. There's no way to know where it goes. You sketch the triangle. You know the triangle has a right angle somewhere. You know the 120 can't go next to the 90 because that wouldn't add up to 180. If I were to extend this way, if that's 90, that's also 90, so it wouldn't make sense to put it there. If I put the 120 here, just threw it somewhere, it's pretty easy to get the one right next to it. The one that's its linear pair would be 60. The one that's down here is 90. And it makes it really easy to find this last one. You know, you could do triangle sum theorem. You could say, well, if this is 90, these have to be complements. So if that's 60, that has to be 30. Either way, you know, the numbers probably make pretty good sense. These are linear pairs, and these have to be complementary. Or you could use the triangle sum theorem here in terms of your justification. So, hopefully an easy one. If you need to go back and rework this, rework this. Otherwise, I expect you're going to go and work on tonight's homework, which is on Schoology. Check it out. Give it a try. Oh, see you in a few minutes.